Hello everyone. Today we will be discussing about the acceleration due to a drum rolling down an inclined plane. So in our BSc Physics Mechanics course. Now let us see. Let us consider the drum to have a mass of M, capital M, and radius B. Radius should be B, and it is rolling down a inclined plane of angle theta. Radius is B and it is rolling down an inclined plane of angle theta. Now what happens? Let us see. See, since it is rolling down an inclined plane, we realize that there are two forces acting on it. One is the force due to its weight, which is actually mg, and it can be resolved into two components, that is mg sin theta or w sin theta and w cos theta. This is the normal component. So this is the normal component which is acting upward. Here n is mg cos theta, and this component is the mg or w sin theta. And there will be an opposing force since it is rolling down an inclined plane. There will be the force of friction which will be opposing it. Hence, the equation of motion will be w sin theta minus f is equal to ma. One more thing I wanted to tell you is how does this theta and this theta become same. See, when you take an triangle, make a triangle like this. This is 90 degree. This becomes 90 minus theta. Then this is again the 90 minus theta. So again this again makes a 90 degree with the plane. So this will be 90 plus 90 minus theta, and so therefore naturally this angle will be theta, and that this angle is the angle with which we will write w sin theta. So our equation of motion will be in the x direction, which is w sin theta minus f is equal to ma. Because in the y direction we will only have the normal reaction which we will not consider, because n will be the upward force will be equal to mg cos theta. So there will be, we will not be interested in the equation of motion there. Now once we have said the force of friction imparts a torque to the drum, as we are discussing about rotational motion and we are discussing about angular momentum. So we will the torque, the force due to friction, there will be a torque associated with it. We know torque means tau is equal to r cross f. Here f is small f, so r cross, here r is b, so it is f cross b. But we know this is making an angle. This is b, actually the radius. So this is b, small b. So f and b are making an angle 90 degrees. So we will write f cross b is equal to fb sin 90 degree is equal to I0 alpha. This is the basic expression, that is moment of inertia into the angular acceleration for a rotational force, that is moment of inertia into angular acceleration. So this is both are constitute equation number 2. Again, we know in rotational motion and translation motion are connected by this expression. Generally we write v is equal to omega r. In this case omega is b, so we will write our translation motion equation expression v is equal to b omega, and our translational acceleration is connected to angular acceleration as b alpha. So using all this, our equation number 2 becomes I0 alpha, instead of alpha write a, by, so we will know fb is equal to ia by b, or f is equal to ia by b square. Let us name this equation as equation 4. You are not doing anything, you are simply substituting for a and b, which is the basic expressions for connecting translational motion and angular rotational motion. So once you are done with it, substitute all these equations in our equation 1. We know mg sin theta, which is our x direction force, minus f is equal to ma. So mg sin theta is equal to ma plus I0a by b square, where I0 is the moment of inertia of the object which is rolling. In this case it is the drum. Now so mg sin theta is equal to m plus I0 by b square, and on bringing a to the left hand side you get mg sin theta by m0 plus I0 by b square. I0 in this case is mb square by 2. So on substituting mb square by 2, we will get our angular acceleration, our acceleration with respect to all other parameters as g sine theta. On substituting I0, we get m plus mb square by 2 by b square, which is 1 plus b square by 2. Or in other words, a is equal to 2 by 3 g sine theta. Here, when theta is equal to 90 degree, then a is equal to 2 by 3 g. So depending on I0, once you know this expression, this is the important expression. Once you know this expression, you can easily find out the acceleration for any objects which are rolling down an inclined plane. So you can make a general expression of it as a is equal to g sine theta by 1 plus k square by b square. We know for rotational motion, moment of inertia is also mentioned as k square, where k square corresponds to the change. M will be same. So k square can be r square by 2, k square can be r square. So that k square you can write. So this is a more general expression. So if it is a disk, it is a ring, whatever is that, substitute for the k square part and get the answer. So that's it. So I hope now you will be able to solve problems where like a ring and disk and a sphere are rolling down a plane. So where ring will have mb square, that is k square is equal to b square. Then you can easily solve because then b square by k square is equal to 1. In the case of a disk, it is mk square is mb square by 2. So there k square by b square will be half. Similarly, you can do all other problems where you take, instead of taking take I as mk square because you are having common m, and take the equation of k square by b square to solve it. So that's it. Thank you.